This testbench is created to verify the functionality of the synchronous FIFO design. Here the first parameter, depth and data width, are declared with values 16 and 8 respectively, matching the FIFO configuration. Next, all required signals such as clock reset, write enable, read enable, and input data are declared as register because they are driven by the test bench. The output signals data out full empty are declared as vice because they are driven by the FIFO module. After declaring the signals, the FIFO is instantiated as the design under test and all test bench signals are connected to the corresponding DOT ports. The initial block generates the reset sequence. Internally, reset is set low, and all control signals such as write enable, read enable, and data in are initialized to 0. After 20 time units, reset is deasserted by setting reset to 1, allowing the FIFO to start normal operation. To simplify the test bench and avoid the repetitive code, a write task named write FIFO is created. Whenever the task is called, it waits for a positive edge of the clock and checks whether the FIFO is full. If the FIFO is not full, it asserts write enable and places the given data on data in. On the next clock edge, the data is written into the FIFO and write enable is deasserted. The task models a single write transaction and can be reused for writing multiple data values into the FIFO. Here, similarly, a read task named read data FIFO is created to perform read operation. The task waits for positive edge of the clock and checks whether the FIFO is empty. If the data is available, it seems read enable. On the next clock edge, the FIFO provides the data in on data out and read enable is deasserted. The task then displays the read data using $display. The task makes easy to perform multiple read operation without duplicate code. The main test sequence starts by waiting until reset is released using wait of reset. Once the FIFO is ready, a series of write operations are performed by calling the write FIFO task with values 11, 12, 13, 14 and 15 in hexadecimal format. Here these values are stored in the FIFO in the same order. They are written. After a short delay, the testbench performs 5 read operations by calling the read FIFO task separately. Since FIFO standards for first in first out, the values are expected to be read back in the exact order they are written, verifying the FIFO functionality. Here, after testing separate read and write operation, the testbench verifies simultaneous read and write functionality. Both write enable and read enable are asserted at the same time. Here in next clock edge, here we are giving both write enable and read enable are asserted at the same time while applying the value AA on data in. During the operation, the FIFO reads one data entry and writes a new data entry in the same clock cycle. Since one time is added and one time is removed simultaneously, the FIFO count remains unchanged. This test ensures that the FIFO correctly supports concurrent read and write operations. Finally, a monitor block is used to continuously display important signal values such as time, write enable, read enable, input data, output data, full flag, and empty flag. Whenever any of these signals change, this provides a real-time view of FIFO behavior during simulation and helps verify that all operations are occurring as expected. After completing all tests, the simulation waits for some time and then terminate using $finish. Overall, this test bench verifies the write and read operations. Here we got an error because DUT module name and here instantiation name is different. Here we forgot about clock initialization. So here we are writing clock synchronization. The simulation starts at time 0 with all signals initialized to 0. Since the FIFO output our internal registers have not yet been reset, data out full and empty initially shows unknown values. At time 5, after 5 clocks edge, the reset logic initializes FIFO. The output becomes data out full 0 and empty equal to 1, indicating the FIFO is empty and ready for operation. The next write operation begins at 25, first data value 11 and applied with write enable equal to 1. Since the FIFO is not full, the data is written into the FIFO and next clock edge at 35 nanoseconds. Write enable returns to 0 and the empty flag becomes 0 because the FIFO now contains one data element. Similarly, data values 22, 23, 22, 33, 44, 55 are written at times 45, 65, 85 and 105 respectively. After each write, the FIFO is increase the